Hey guys, this is CHEMPLIFIED and today we will talk about Saytzeff rule. It also goes by the name ZAITSEV, Saytzeff rule. In my video I will call it Saytzeff rule. So let's start with the statement. Before we start the statement, there is a thing that you should know, that Saytzeff rule comes into play if there is a possibility of getting two different products in a particular reaction. And in this video we will talk about alkyl halide in particular. So let's start our first statement. There are two statements for this that I have written. First one is, if more than one elimination product is possible. So first of all, elimination reaction will be there, and in that elimination reaction the possibility of getting two products is there. Then the most stable product or major product is the most substituted alkene. Now the formation of two product is possible, out of which one will be major, one will be minor. The major product will be most substituted alkene. What is the meaning of most substituted? First of all, let's draw an alkene. Now this is an alkene. Now this is non-substituted. There is no substitution in this particular alkene. But if I add one more carbon, now this is substituted alkene. And let us suppose there are hydrogen, right? Let's keep it there. And there is another alkene on which both side there is carbon. If somebody asks which one is more substituted, the first one or the second one, then the second one is more substituted alkene, because on the alkene part on both side one carbon is attached, right? And in this particular case only one carbon is attached at one, and at one side, the other side don't have any substitution. So highly substituted means that have more number of substitutions on the alkene part, right? So most substituted, in our case second one is most substituted. Now let's move to the second statement. In this particular statement we will talk about alkyl halide. If dehydrohalogenation, what is the meaning of dehydrohalogenation? Have one hydrogen and one halogen will be moving out. Dehydrohalogenation. In dehydrohalogenation of alkyl halide, if it can yield more than one alkene, then according to Saytzeff rule the major product is most highly substituted alkene, right? So this statement is same, most highly substituted. Let's take a look at the example. Now this is an alkene, sorry, this is an alkyl halide. Now after the dehydrohalogenation, means after the removal of this bromine and one of the hydrogen, either from this carbon or from this carbon, the possibility of getting two products is there. First one is 2-butene and the second one is 1-butene. Now let me tell you, this one is major. This one is major product, 80% yield. This one is minor, only 20% yield. This is known as Saytzeff product. Saytzeff product. And this one is known as Hoffman product. This one is Hoffman product. Why this is happening, why this is major and why this is minor, we will talk about it in the mechanism. Let's go for that. I hope you understood till now. Let's talk about the mechanism. Now we have to remove one bromine group, so let there be any group that can abstract halogen, like alcohol KOH or NaNH2, right? Now the first step is removal of bromine, so we just remove it. I will erase it. When bromine is removed, there is a carbocation, right? And In this particular situation, there are two alkenes possible. Let us make those alkenes. First one is this one, and second one is this one. Now, the major and minor product is decided by number of hyper conjugations. What is hyperconjugations? Hyperconjugation is transfer of CH sigma electrons into conjugation. It will not take place in this reactant, right? It will take place in the product side. And in this particular case, this is ZZF product. Two more hydrogens will be there. This is ZZF product, 80% yield. In this particular case, two hydrogens will be there, one is there and three are there. Now, what is it that decide hyperconjugation? That is alpha hydrogen. Alpha hydrogen present on alpha carbon. Now, what are the number of alpha carbons that are present in this particular case? This is the alkene part. The first carbon, the next carbon to the alkene is alpha carbon. So here two alpha carbon are there. Now in this particular case there is only one alpha carbon, right? Now how many hyperconjugations are possible? Is how many CH bonds are there that can donate their sigma electrons. So in this particular case there are two hydrogens or two CH bond that can donate their sigma electrons into conjugation. And in the above case there are 1, 2, 3, 4, 5, 6. There are 6 CH bond that can donate sigma electrons into conjugation. So the number of hyperconjugations decide the major and minor product. Higher the number of hyperconjugations, major will be the product. Or this is also the most substituted. Now this one is most substituted alkene. This one is least substituted. There are only two products. This one is least substituted. This is most substituted. Also remember, there are more than one means there can be three products possible. For example, if I put CH3 at this place, if I put CH3, then this carbon can also go for hyperconjugation. So I can make double bond at this side and this side. So there are three possibilities. So in this particular case, three products will be formed. We will keep ourselves at 2. So higher the number of hyperconjugations, major will be the product, or Saytzeff product will give highest number of hyperconjugation. This was your Saytzeff rule. I hope you understood Saytzeff rule. This will be it for today's video. Thank you very much.